Can you hear? Is the microphone working? It sounds like it's working. Thank you. Don't we all love the web? But then don't we know that there are many not so nice things happening on the web? Many web-based malware, drive-by download attacks, phishing pages. Which we do know because many of you have developed a web filter. And today I'm going to talk about the web filters. And more specifically, I'm going to talk about how to test web filters, how to test the performance of these web filters. But before I go there, let's agree upon what is a web filter. Now, in general, at least during this talk, a web filter is a device that filters HTTP traffic. And most typically, it is set up as an HTTP proxy. And it's set up on the edge of an organization network. What a web filter does not do is protect against man-in-the-browser attacks. It does not prevent malware running on a machine for modifying what the browser displays. Nor does a web filter protect the web itself. It does not prevent SQL injection attacks, or it doesn't prevent websites being compromised because they run an outdated version of WordPress. But most importantly, a web filter is not a URL filter. It does not decide between good and bad URLs. It's true, many web filters may do this. Many web filters may be set up as a URL blacklist. And there's nothing wrong with that. I'm not making a judgment on it. But that's not how the web works. The web is more complicated than URLs being good or bad. So let's see what variables the response received from the web depends upon. Well, first there is, of course, the URL. And that's stating the obvious. Different URLs give different responses. That's how the web works. That's why the web works. And secondly, there's the IP address. We've all visited Google from a foreign IP address, and suddenly we saw Google use a different language. And some kinds of web-based malware use this too. Use localized versions of the malware depending on where you visit from. Then there's the time. Websites change over time. Malicious sites change over time. In fact, malicious sites tend to get taken down quite quickly. So a site that's malicious today may give a 404 tomorrow, or domain not found, or perhaps it was a legitimate site that was compromised and it will have been cleaned up. But time matters too when you combine it with the IP address. Last year at VB 2011, Nick Fitzgerald, who actually was editor of Virus Bulletin in '97, he gave a presentation on distributed one IP malware. And the idea of that is that there's a large number of malicious websites that together only attempt to infect every IP address once. And the reason is that there's some kind of affiliate scheme behind this, and the bad guys, they don't want to pay twice for infecting what's probably the same device. So when you make two requests from the same IP address from your testing lab, the order in which you make them, even if they are to different websites, the order in which you make them may matter. So time matters here as well. Then there are the HTTP headers that are sent by the browser. Take, for example, the referrer header. It's quite common for attacks using search engine optimization to only redirect users to a malicious site if they came via search engine or if they came via Google. And this is what the referrer header stores. And also part of the header are cookies. They contain, for instance, login information. If you attempt to visit a malicious site, say over a malicious Facebook page, it may be that you only get to see something bad, something malicious, if you if you're logged into Facebook. That is only if the cookies sent by the browser show that you're logged into Facebook. And then there's the browser, which includes all the plugins running in the browser and the operating system the browser runs on. For example, a lot of web-based malware uses as the first infection vector. If you run a browser with no script, then nothing malicious will happen on the network. No malicious HTTP traffic will be sent because no JavaScript is running. And a lot of web-based malware depends upon users running vulnerable plugins. We all know that. So there is a legitimate plugin called Plugin Detect, which is a server-side plugin, which websites can use to detect what plugins and what versions of them the user is running. And for instance, the black hole exploit kit uses it. And it only, so if you're not running anything that can be exploited, it may not attempt to infect you. So there are 5 variables that determine the content of the response. Sorry. Not my computer. 5 variables that influence what is returned from the web. Hold on. It's not my laptop. This is some kind of fake antivirus. I'll try that again. I'll click cancel. And nothing happens. This presentation is written in HTML. This fake AV page you just saw is loaded in an iframe. It only loads if you click OK. And I know that because I wrote the HTML. And there's an important lesson in this. Human interaction like this does matter. It is tempting to think of a URL being opened inside a browser, an HTML page being returned, some images, some CSS being loaded, and that's it. Then this is a static website, and nothing happens until you load the next URL. And that was what the web was like in 1997. That's not what the web is like today. Users do click on buttons, they start typing text, they move their mouse, all of which modifies the way the website is displayed. And they do generally generate new HTTP requests. And as this example just showed, although there was no HTTP involved, but as a proof of concept, it could change the maliciousness of a website. It could turn a legitimate website into something malicious without opening a new URL. And this is not some kind of proof of concept that I'm doing here to show off my HTML skills. This is used by malware authors. This is a piece of JavaScript from the nuclear exploit kit. Guys from ESET, Alex from ESET put it on their blog. And if you look carefully at this piece of code, you notice that something malicious will only happen if you move your mouse. And it's clearly an attempt to trick scanners that automatically scan the web into believing nothing bad happens on that website. And of course, this affects someone running a web filter test as well. So there are, in fact, 6 variables that determine the response. And it's important to keep this in mind. But then it's equally important to keep in mind they're not all of equal importance. You don't run a web filter test by keeping the URL fixed and making requests from different IP addresses. That's just silly, and I think we all understand. So in most cases, it's the URL that really matters. And you can, in some sense, talk about malicious or potentially malicious URLs. So I'm not even saying that you should always vary the other variables. You should change the IP address if you run a test every time. I'm just saying that it's important to keep in mind whatever choice you make here affects what you get back. But the URL is the most important. So what would you need to get is potentially malicious URLs. There are 2 problems with this. The first one is that there are a lot of them. A few months ago, Google reported that there are about 9,500 of them. I've heard numbers that are actually much higher, but even if this is true, and even if we would be able to get all 9,500 malicious URLs. I don't think a test setup, at least the one I have in mind, allows us to test this many sites every day, and not even close. So you have to use some kind of sample, and you have to make sure that the sample is representative. And there's a second problem with getting malicious URLs, or potentially malicious URLs, that there actually aren't very many of them, if you look at it in a different way. This is from a Barracuda report in March this year. And they basically said that, on average, of the websites, about 1 in 10,000, or slightly less than 1 in 10,000 was malicious at any given day. Now, I'm quite certain that in the lower echelons of the web, the situation is a lot worse. But even if it's, say, 100 times worse, that would still mean that only 1 in every 100 websites is infected. So unlike, for example, with email, where the majority of emails is spam, and that's very useful if you run a spam filter, you test a spam filter. You just get a lot of emails, and automatically a lot of them are spam. In this case, just taking random URLs gives too much, well, noise. And noise in this case are legitimate, good, unharmful websites. So we would have to actively search for malicious URLs. So you could look for them in spam. You could look for them in Twitter spam, which is very public. You could look for patterns of compromised websites. You could also look for search engine results for trending topics, possibly the second page of Google results. That tends to be a lot of malware hanging out there. And of course, there are vendor-based schemes that where vendors share a list or feeds of malicious URLs. And we could use these if they're willing to lend them to us, which they may. Which would say, that of course would save us a lot of work, but of course the problem with that is that tests may become biased. So that's all something to keep, everything like this has to, this all has to be kept in mind. Now I've been, throughout the past 10, 15 minutes, I've been speaking about malicious URLs and malicious websites. But what do I mean by a malicious URL? Or a malicious site, sorry. I don't think there's a clear definition I can come up with, and it definitely depends on the context you're running a test in. So rather than impose my own definition of what is bad, here are some examples that probably highlight some of the choices to be made. Does anyone recognize this? This is the landing page of Black Hole, or one of the versions of Black Hole, exploit kit. And it goes further than this, but this is the first thing you see, or the first thing I see when I run it in a safe environment. I think we all agree that these pages, if they really generate malicious HTTP traffic, should be blocked. This is a Wikipedia entry for a black hole. I think we all agree that this probably shouldn't be blocked. This is a recent example, an update for your YouTube player. That's pretty bad. This cute bunny, I think many of you will recognize it. And the corresponding website isn't malicious in any way. But I think you'd have to think twice if you want to use a site like this for testing for false positives, because I think it's somewhat understandable if the site is blocked, especially in a corporate environment. This is the worst joke of the presentation, sorry. This one, I've seen it before. This is fake antivirus. And I think we all agree this is bad, it should be blocked. But this particular one, and it was, I mean, I created the HTML myself, but it's based on a real example I downloaded from the internet a few months ago. This particular one does not do anything to your computer. There's no malware involved in a traditional sense. It's pure social engineering. So I think it should be blocked, but I think it's important to realize that it's a different category than, say, Black Hole, which installs malware. And a similar example in that category is this website, which is Canadian Neighbor Pharmacy. it's spam, it's bad, it's illegal, it should be blocked, at least I think, but it's a different category than pure malware. Okay, I've mentioned false positives already, and I think we do need to test for them. And I think we all know what a false positive is. It happens in this context when a web filter blocks a good response, good website, but it shouldn't block. But I think it's also important to realize that when you're gathering URLs, you may find a lot of URLs that aren't bad. A lot of spam contains purely harmless URLs. But I think if you want to use them as test for false positives, you need to have some kind of evidence that the particular URL was seen in a legitimate context. And spam is not a legitimate context. Okay. So I think we have, or I hope we have, a good idea of what is involved in running a web filter test, or at least some of the things. So we want to run a test. That's why I'm going to talk about it. I am developing a web filter test for Virus Bulletin. And we have a wish list of things we want. Now, firstly, we want to run a relevant test. So the test setup should be as real as possible. And secondly, the test results should be meaningful. So we should ensure that it's statistically sound. And thirdly, we, Virus Bulletin, and we're not the only ones who really believe in running comparative tests. So it should be comparative. And finally, we don't just want to run tests. We don't just want to tell which products are good or bad. We also want to help participants to improve products if it doesn't perform very well. And we want to give feedback. If you remember my presentation, or if you saw my presentation 3 years ago on spam filter test, these 4 items on the wish list are basically a rewarding of the 5 criteria of the ideal anti-spam test I gave back then, a rewarding and a regrouping. Okay, so let's put theory into practice. This is a web filter. We want to test it. We want to see what makes it through it. And of course, you want to compare it with what went into it. And I've said we want to run comparative tests, so we need to do this for multiple filters. But you can only compare when they make the same request. So they need to make the same request. And you need to make sure, because I've talked about the importance of the browser, that they use the same browser, and the same operating system. So an exact copy of the same virtual machine makes sense in this context. But then I said time does matter, and you can never make, and time and order in which you make requests matters. So you can never make multiple requests at exactly the same time. So you need to store a local cache of the request you make. To fill in this cache, you create another copy of this virtual machine. And we use this to make an unfiltered request, and we use this to fill the cache. And these boxes containing the cache, they will be cleared for every new request is made. And it will be stored, of course. We could do something like they contain all the responses in separate files, and you can glue them together with some XML or JSON, and you zip them, and you get one file that you can send to vendors and say, you blocked this and you shouldn't have, or you didn't block this but you should have. And they can analyze it. And we can analyze it later on. But what about HTTP headers? I mentioned that they're important, that they can influence what you get back. And of course, browsers by default, if you set up standard, do send headers. But you might want to send some extra. You might want your test machine to be logged into Google or Facebook or Twitter, if you believe this will be more realistic. You may also decide to send a referer header depending on in which context the URL was found. And which browser to use. And which plugins to use in the browser. And there's a conundrum here. I mean, on the one hand, we all preach the importance of patching, of running an up-to-date browser with all the latest versions of all the plugins. And on the other hand, the reason we say that is because we're the reason we say that is because we're very well aware that this significantly reduces the chances of something bad happening. And that's perhaps not very when you run a test. So running a test with slightly older versions might be more interesting. And I don't think there's a right choice to be made. I don't think there's a right version of the browser. But what may work is running a test in two parts. One part with completely up-to-date browser with all the latest plugins, and one part of the test with a slightly older version of everything, but still something that is reasonable to expect people to use. And of course, human interaction. I mentioned that it is important to realize that. Well, no interaction is also a form of interaction, and I'm afraid for the time being we may have to settle with not using user interaction, because emulating interaction is very tricky in a lab environment. And it's even trickier if you want to emulate exactly the same behavior over multiple machines. But it's an important issue, and it's one that we haven't solved, or I haven't solved. And comments and suggestions are very welcome. And there are other things that we should consider. What about response times? I mean, it's one thing if your filter is very good in performance, blocking the right things. But if it takes several seconds to check any website, then it significantly makes your experience of using the web significantly worse, and people might not want to use that. I wouldn't want to use that. What about secure HTTP traffic? A lot of HTTP traffic is sent over a TSL or SSL, TLS or SSL connection, and that's a test environment should allow. But so that means you have to work with local versions of the certificates, local certificates. Sorry. And then there may be other issues we haven't foreseen. I mean, I do think the plan we have it's reasonably sound, and we have more details, more technical details. But I'm also well aware that when we start putting this into practice, that things may not work as we expected, or perhaps web browsers will change significantly, or perhaps malicious sites will change significantly. We may have to adapt, and I think all we can do is keep our eyes open and be aware of these changes, and adapt when needed. Thank you.
First, let's thank the speaker. And now we do have time for a few questions. Over there.
So I guess the question here is, when you look at the environment you're going to try and replicate, are you focusing on sort of the end user at home, corporate environments, military installations? Like what types of situations do you want to simulate? And as a second part of that is the ability to interact, modify, or adjust your own content and blocking capabilities. Rule-based installation versus having to rely completely on a reputation system from the vendor. Are these going to be factored into your types of decisions as well?
Yes. Sorry, we don't have an answer yet to what environment, if it's a home use or a business environment, we want to emulate. We may want to do both, and obviously we don't intend to run more than one test, so we probably will do each at a time. I think web filters are far more used, especially as HTTP proxies in a business environment. But yeah, there's no. As for your second part of your question, okay, can you tell? Sorry, I'm forgotten what. Just briefly, because I.
Okay, I won't mention vendor names, but certain major vendors out there.
Okay, about setting up stuff and things.
Well, no, not specifically. They tend to rely more on sender base scores, reputation of IP addresses, domains, et cetera,
Yeah.
whereas others will be somewhat more generic and give you the ability to profile your user's traffic and categorize what types of blocking or what sort of more of an anomalous type blocking behavior rather than
and how we're going to set this up, basically. What decisions we're making about what profiles to choose. It's still an open. The question is still open. What I've done in the anti-spam test is ultimately give the decision over to the vendors. Say, this is what we're testing. This is our setup. Use the settings that you believe are ideal for this situation. Okay.
No. There's a question over there.
My question is related to the last question. You mentioned the fact that you use cache for test consistency to make sure you always get the same content from different machines over time, and that makes perfect sense.
Yeah.
So how do you compare results when some products prefer to access directly to the web because they rely on IP reputation, URL reputation, versus those products that use the cache because they do deep content inspection?
I do intend to do it almost real time. So the idea is the cache is filled in real time, and then as the products check this, what comes back from the cache, as if it comes back to them from the web. So there's a small delay of probably a few seconds, but not much more. So using the web to check results in real time shouldn't be a huge problem.
But does it happen that you have to repeat the test, say, a week or 2 weeks later? Because if you use a real-time cache, like you mentioned, then the content of the website might change.
Yeah, no. If I want to use the same URL a week later, I need to use a new cache. I need to fill the cache again. You know, I wouldn't. I know. Yeah, as I said, malicious sites are taken down next hour sometimes. So yeah, I think it's very important.
There are some solutions out there which change the default gateway, or in some special cases also only the proxy, and filter, redirect the whole traffic to some remote websites for analysis, eventually also sandboxing them, and then sending back filter to the user. How do you plan to integrate something like that?
Sorry. Can you
what happens with the solutions that redirect the whole traffic to some remote site for analysis and then send back the filtered traffic?
I've spoken to someone, and I won't name the company, but someone from a company who has a cloud-based solution, basically. And they said it could probably be set up probably on a test, on a development server at their site to use our site as a second proxy. So requests are made to the cloud, their part of the cloud makes it back to us. But yeah, it depends on how a participant is set up. I mean, even with the VB spam anti-spam test, there are some products that work in a way that I can't really test. That's life, but I don't want to give up. But yeah, there may be products that can't be tested in this way.
One last question.
Yeah, so you covered a lot about, you can call it like URL reputation. Are you intending to go also into categorization? So in a corporate environment, the quality of the categorization, gambling, adult contents, and so on is probably just as important.
Yeah, I agree. I mean, initially I want to make it a binary test, good or bad, and probably a lot of things in between that I'll just throw out, but good, bad, good sides, bad, but the next step is to use categorization and to see correct categorization. What I'm a bit worried about categorization is that there's something subjective there. That, yeah, things that, yeah, is this really gambling, or is it just a bit of a game where, yeah, that sort of questions. I'm not sure if I want to go in there, but it's definitely some kind of categorization I definitely intend to test for.
Okay, I'm pretty sure if there are more questions, Martin will be here all
Yeah.
times, so you can find him anywhere. So thank you, Martin.